Okay, this is about dummy variable. The simplest possible example for dummy variable. We defined a dummy variable for man and another dummy variable for women. Okay, so first question, and mu m is defined as expectation of y given, like say male, and mu f is expectation of female, conditional expectation. Okay, pretty simple. First, yeah, let's see why this does not work. Okay, A, we think about this model, why it's not identified. You may just say like it in same thing in different ways. You may just say that 1 plus m 1 equals, excuse me, so 1 equals mi plus fi. So linear dependence. This is also reasonable answer, I think. And also you may choose alternative parameter value that is observational equivalent. How do we do that? I'm going to define beta 0 equals to 0, beta tilde equals to 0, gamma tilde equals to 0. Something is wrong. Sorry, it's wrong. My bad. The other way. I have to, so I will find observational equivalent one. Alpha tilde, I will assume 0, and beta tilde is beta 0 plus alpha 0. Gamma tilde equals gamma 0 plus alpha 0. Then let me rewrite the equation. So alpha 0 times, we have alpha 0 times 1. So instead of 1, I'm going to include this, and beta 0 mi plus gamma 0 fi plus ui. That is same thing, just I replaced one hidden multiplication 1 into m plus f. That means, so terms for m, like factor out m this way, and then for f, okay, this is exactly my definition. So it's alpha tilde plus beta tilde mi plus gamma tilde fi plus u. Okay, so in that way we could prove identification failure by showing observational equivalent parameter value. Okay, then what is the next question? Show that this is identified. Okay, actually to be more exact, I have to find conditions. So for these two cases, find conditions for identification. Also, you know, it is too obvious, then what can I say that? Mathematically, what you do here is you are going to show that full rank assumption is satisfied. Okay, we will show this is invertible where x is 1 and what was that? 1 and m here. And I will write theta as alpha 1 and beta 1. So, is it right? 2, 0. Sorry about that. Alpha 2, 0, beta 2, 0. So our model is y equals to alpha 2, 0 plus beta 2, 0 mi plus ui, and we'll use the general vector notation like this. And then expectation xi transpose can be written as expectation of, excuse me again, a matrix with 2x2 matrix, 1 expectation of m, expectation of m, expectation of m squared. Okay, right now, so first, one thing you have to think about here is m is 1 or 0. Okay? Then when m is 1, m squared is 1. When m is 0, m squared is 0. So m squared is always m. Okay? So as a result, I could rewrite this as this way. I'm using result 1. Okay? And now I will simplify another thing. Let's say probability of mi equals to 1 is p. P is the parameter for the probability. And then expectation of m is p times 1 plus 1 minus p times 0, because m takes 1 with probability p and 0 with probability 1 minus p. So then this is 0, the second term is 0, so expectation is always p, right? So usually in this case, we write this as 1 ppp. So this is from the second result, from the second fact. Now then, it's simple. 1 ppp, its determinant of this matrix is 1 times p minus p times p squared. This determinant should not be 0 for this to be invertible. Okay, determinant should not be 0. Then it's a familiar form. For this to be non-zero, p cannot be 0, p cannot be 1. And, okay, p, because it is p times 1 minus p. Both cases, this is probability of man, and this is probability of woman. So neither should be 100%. So what this means is you have to observe some women and some men at the same time. If 100% of your sample is woman or 100% man, then identification fails, because in that case, this variable is constant. If not, right, that is the idea. So mathematically, this is how we prove it, okay? So this is part B. So I find conditions, and from there, I think it should be straightforward. Like exogenate assumption is, I didn't say that. So you have to check exogeneity and for rank. So if you take those two, then you are good. You can identify the parameters. Let me do the same thing for C. Exogeneity should be stated and assumed. C is just no difference. Y is beta 30 mi gamma 40 times 30, excuse me, 30 fi plus ui. By the way, if you wonder why I'm using, say, 30, why not just same gamma here, then the answer is when you change the equation like from here to here, the coefficient also changes. Depending on which regressors you use, the coefficients may be different. So also I had to write different u here. I should have, because depending on the regressor, the error term might be different. Actually, it's not in the end, but that's just that's because I know the result. But when you define a new model, you have to assume they may be different, and then you have to prove that they are the same or not. And when they are same, then you may use same notation. Anyhow, come back here. In this example, I'm going to have vector notation like this. So again, I am going to calculate this matrix and its determinant. How do we do that? This is expectation mi squared expectation MIFI, expectation MIFI, expectation F squared. Okay, so then how can you simplify that? You know, square does not affect, okay, like this. Then m times fi. There are only two possible cases for this random variable, when m is 1 and when m is 0. When m is 1, f is 0. When m is 0, then f is 1. Either case, it's always 0, right? At least one of them should be 0 all the time. So the off-diagonal terms are 0. And then we define probability p, the parameter p as the probability of man. Then it can be written as this. So its determinant is p times 1 minus p. Okay, same thing. So we need the same condition as before. Now then, the last one, express beta 20, beta 30 in terms of the conditional mean. Okay, let me write the equations. Beta 20 has intercept. It's not x, it should be m. This is the second model. Beta 30 mi plus gamma 30 fi plus ui. And remember, we defined expected wage for male in this way and expected wage for female. So definition, yi female. I am going to express the parameters using those statistical objects. So what does it mean? Like, so those parameters are just our assumptions, right? Those parameters do not exist, right? I just assume they are the coefficients of those random variables. But these are like tangible statistical objects, right? So that's similar to why we, in general, in the classical linear regression model, we wanted to show that this, because right-hand side has substance, it's expectations, but it is just a Greek letter. It's an alphabet, or what? We have to show what this alphabet corresponds to in terms of the data, right? So we are going to do something similar in a similar spirit. So let's think about the first case. In the first case, I will calculate expectation of yi given male, which is mu m. That is, if you change y with alpha 20 plus beta 20 mi plus ui given m, male, m equals to 1, then you can write this as alpha 20 plus beta 20 expectation mi when mi equals to 1 plus expectation ui when mi equals to 1. So I forgot to mention this in the question. I have to assume this equals to 0. That is the exogenate assumption. And of course this is 1. Always 1, because when m is fixed as 1, it is 1. So that is male conditional expectation for man. Conditional expectation for woman. Then this is the same thing. Same thing to right. So of course I simplified. You have to write 0 here. Anyhow, the last term should be 0 by the exogenate assumption. and this term is 0 because when you condition on m equals to 0, automatically m is always 0, so you don't need to think much about that. That means we get mu f equals to gamma 20, alpha 20. So the intercept captures the mean of the reference group. Because in the first equation we dropped female dummy, so the female mean is captured, is observed into the intercept. Okay. Meanwhile, like man's average wage is like this, so that means beta 20 is mu m minus mu f. Right? As I said, coefficient of the included group is the difference from the reference group. So that is also proven here. I am going to do the same thing for the second model, beta 30 mi, gamma 30 fi plus ui. So let's do conditional wage for man. That is beta 30 expectation m given m, it should be 1, plus gamma 30 expectation f given m equals to 1 plus expectation u given m equals to 1. Okay, as before, it is 1, it is 1, this is 0, this is 0 by exogeneity, so it's simply beta 30. In the same way, woman's average wage is for woman, first, exogeneity should be assumed so that it is 0. And of course, this is 1. Whenever f is 1, then it is constant. And whenever f equals to 1, m is 0, so this should be 0. So in the end, we get gamma 30. So in this model, what you have to see here is, as I said, coefficient of m is now just mu m, because there is no reference group here. The reference, what is dropped is the intercept. So each coefficient should play as if they are the intercept, right? That means, anyhow, beta in this model is solely mu m, but in the previous one, beta was mu m minus mu f. So depending on which model you are using, the interpretation should be different. Identification should be different.